everybody, this is Miss Mitchell, and today we're going to be doing a Chapter 4 study guide walkthrough. So hopefully you guys have all looked at and completed your study guide, and now we're going to go over it. This will hopefully answer any questions you may have or any problems you were unsure of how to work. So hopefully you know by this point that our study guides are pretty spot on with the test, so if you can do all of the work on the study guide, you should be golden for the test. So our first problem tells us to simplify each expression. So just by looking at these, we've got some multiplication and some division. So remember, when we multiply exponents, we add them, and when we divide exponents, we subtract. So let's start. We have to distribute this 3x to the fourth power over. So notice that this is one term. It's not separated by a plus sign or a minus sign, so it's not being distributed over twice. You are just carrying it over once. So we have 3 times 5 is 15, and then we have x, 4 and 4 is 8, and then y to the second power, and that's your answer. All right, and then on B, we're dividing, so we have 6 divided by 3, 2. 6 minus 2 is x to the fourth power, and then 4 minus 8 is y to the negative fourth power. Now, remember, we cannot have any negatives in our answers. So we need to get rid of this negative 4, and we can do that by putting it on the bottom of a fraction. So this is going to equal 2x to the fourth power, y to the fourth power. Remember that this y has to come down with the exponent, that they belong together. Okay, and now we've got a squared term, right? So that means that we're going to do negative 2x y to the fourth power times negative 2x y to the fourth power. So it's multiplied by itself. So I have negative 2 and negative 2 is going to be positive 4. X and x gives us x squared. Y to the fourth power and y to the fourth power gives us y to the eighth power. Okay, remember that anything raised to the power of 0 becomes a 1. So this whole thing does not become 1, but this xy to the fourth does, because this is what's being raised to the 0 power. So this becomes 1. So 1 is being multiplied by this, so we're just going to copy that down. 3x fifth y squared, and that's your answer. All right, 3 divided by 6 cannot be divided, but can be reduced to a fraction. That reduces to 1/2. And then we have negative 2 minus 5. So negative 2 minus 5 is going to give us negative 7. So if you wrote that out, you would have x to the negative 7th power, and you would have to put it on the bottom to get positive. So we have that on the bottom. And then we have no y's on the top and 1 y on the bottom. So we're leaving that y there. So this is our answer. Make it a little prettier, 2x to the 7th power over y. All right, and then once again on F, notice there are no plus or minuses that are going to cause us to distribute to more than one term. These are just single terms being multiplied. So we don't have a coefficient, but remember there's an imaginary 1 here. So 6 times 1 is 6. Then we have 6 and 4. So that's going to be x to the 10th power. And then we have negative 5 and 0. Remember, this is 0 is going to be raised become 1. Not this whole thing will not become 1, but just this y becomes 1, because that's what's being raised to the power of 0. So we just are going to be left with y to the negative 5th power. And of course we have to get rid of our negatives. So we have 6x to the 10th over y to the 5th power. All right. It wants us to find the factors that equal to this simplified sum, right? So the first thing we need to do is find out what factors were pulled out of this box. So I like to start by going across the top. So what is a common factor of 10x and negative 5? Well, it obviously isn't negative because this is positive. So that means that this number is going to have to be our negative. So this is going to be positive, and 5 will go into 10x and also negative 5. All right, and then 5 times what is going to give us 10x? So that's going to be 2x. And then 5 times what gives us negative 5? And that's going to be negative 1. All right, so that takes care of our first two boxes. Now, negative 1 times what gives us negative 2x? Right, 2x. So does 2x and 2x give us 4x squared? It does. So we know that that is going to be right. So remember, we take our terms and we make a little problem out of them. So we have 2x plus 5 times 2x minus 1. And then we distribute that out using the FOIL method. So remember, it's first, outer, inner, last. So we have 2x times 2x. It's going to be 4x squared. I'm writing it up here because I may have to simplify or combine like terms. Right, and then we've got 2x times negative 1. It's negative 2x. 5 times 2x plus 10x. And then 5 times negative 1 is negative 5. So we have two terms that can be combined. So we have 4x squared. Negative 2x and positive 10x are going to give us positive 8x minus 5. All right, now we've got some where we need to fill in on the outside and on the inside. So let's start with what we know. Negative 2 times what is going to give us negative 18x? Well, 9x will give us negative 18x. All right, and then 9x squared times what is going to give us 27x cubed? Well, 9 times 3 is 27, and we need one extra x, so we'll do 3x. All right, and now that we've got our two missing numbers, we can fill in the rest of the box. So negative 2 times 9x squared, negative 18x squared. 3x times 9x, 27x squared. Negative 2 times 5, negative 10. And 3x and 5 gives us 15x. All right, and then we make our problem. So we have 3x minus 2 times 9x squared plus 9x plus 5. Remember, unless there's a negative symbol in front of it, you are adding them. All right, so now we can go ahead and distribute. And what you'll notice is this has already been solved. So we can look at this box and go from there. So our first number is going to be 27x cubed, because all this rectangle does was already distributed this problem out. So 27x cubed. All right, now we've got to do squared. Remember, we go in the order of exponents. So we have negative 18x squared and 27x squared. Okay, so remember that you have to do your highest number of exponents first, followed by your least amount, and then the coefficients that don't have any at all. So now we've got 9x squared, because 27 minus 18 leaves us with 9. And we're not changing the exponents on this, right? Because these are just being combined. These are like terms being combined. Okay, now we have negative 18x and 15x. That's going to give us minus 3x. And then we just have negative 10. And that's your answer. Alright, so now it says to use the distributive property or a generic rectangle to simplify the following expressions. So for these two, I will do the just regular distributive property, and then I'll show you the box method on these. So remember, we use FOIL, first, outer, inner, last. So 2x times 3x, 6x squared. 2x times negative 5, negative 10x. 1 times 3x is 3x. And 1 times negative 5 is negative 5. And then we just combine like terms. So we have 6x squared, and then negative 10x and positive 3x is going to give us negative 7x minus 5. All right, I'll go ahead and get this one out of the way. Remember, if the whole thing is squared, you're multiplying it by itself. And then we'll distribute this out. So 3x times 3x is 9x squared. 3x and negative 4 is negative 12x. 4 and negative 3x is negative 12x again. And then negative 4 and negative 4 is positive 16. And then we combine our like terms. So we have 9x squared, negative 12x, and negative 12x. Remember, these are not going to cancel out. These are both negatives. So this becomes negative 24x plus 16. Okay, and now we're going to use the rectangle to solve for these. And I'm going to show you on these because we've got 3 terms. So let's see, we need 3 this way, and we need 2 this way. Should be big enough. All right, and then remember, we just fill it out. So we have negative 2x squared, 1x squared, 7x, and negative 4. So we have 1 times x squared is x squared. 1 times 7x is 7x. 1 times negative 4 is negative 4. Negative 2x squared and x squared is negative 2x to the 4th power. That doesn't look like 4. Negative 2x squared and 7x is negative 14x cubed. And negative 2x squared and negative 4 is 8x squared. All right, now we just need to look at our box and combine some like terms, starting with our highest exponent. We don't have any other cubes, so we have that first, negative 14x cubed. We've got x squared. Oh, I'm sorry, I didn't even see that 4th power. Hold on. So we have a 4th power, so that should go first. So we have negative 2x to the 4th power. Now we can use our cubed minus 14x cubed. X squared and 8x squared is 9x squared. 7x, there are no other single x's, so plus 7x, and then minus 4. All right, and I was going to do the box method for this, but I realized it's just one term, so this one term is just being distributed out to the 3 separate terms. So 5x to the 4th power times 2x cubed. 5 times 2 is 10x. We have 4 and 3, so we have 7. 5 and times 6, negative 6 is negative 30. And then we've got 4x and 2x, so we have 6x. Then 5x to the 4th power times 4, so we just do 5 times 4, and we have 20x to the 4th power, and that is our answer. Remember, feel free to pause this video at any time and rewatch anything you may not understand. Oh, didn't mean to do that. All right, now we're just solving for the specified variable. So first, we're solving for y. So we have 2x minus 3y equals 18. Hopefully you guys remember that we're doing PEMDAS backwards. And we talked about this also being a G. So for any grouping symbols, not just parentheses, but we're looking at fractions, square roots, brackets, and also parentheses. All right, so we're solving for y. So the first thing we need to do, subtract 2x. We have negative 3y equals, let me write it the other way, negative 2x plus 18. We want y alone, so we're going to divide by negative 3. And we get y equals negative 2 divided by negative 3 is going to become positive, right? Remember, negative divided by negative is positive. So we have 2/3 x. This obviously can't be divided. But then 18 divided by negative 3 can, and it will give us negative 6. Okay, now we're solving for x. So we're going to do the same exact thing, but opposite. So we're going to add 3y to both sides. 2x equals 3y plus 18. And we're going to divide by 2. And then we get x equals 3 divided by 2 cannot happen, so we're just going to leave that as a fraction. So we have 3 over 2y, 18 divided by 2 is 9, so plus 9. Okay. Now, we need to first distribute this out before we can solve for anything, right? So we have 4x plus 5 equals negative 4 distributed out. It's going to give us negative 8x. Negative 4 times 12 is going to give us negative 48. And now we need to move one of our x's to the other side. I'm going to choose to move this 8 by adding 8x to both sides. Now we have 12x plus 5 equals negative 48. Now we need to get rid of our 5, combine some like terms, so we're going to move that to the other side. We get 12x equals negative 53. And then we're going to divide by 12 because our last goal is to get x alone. And we get x equals negative 53 over 12 cannot be changed. So we're just going to keep that the same way, negative 53 over 12. And if you get an answer like this, don't think that you're wrong. I know it looks crazy and looks like you think you may have messed up, but this is the right answer, so don't doubt yourself. Okay. Now we're solving for t. So notice we've got r times s times t squared. So these are all being multiplied by each other. So t squared is being multiplied by rs. So we can just divide by rs. Right, now we've got w over rs equals t squared. And in order to get rid of the squared, we take the square root. So we get t equals the square root of w over rs. That is your answer. All right, and last one, we're solving for b, which is right here. So we're going to start by moving this AD to the other side. So we're going to subtract AD. If you have separate terms that are not being multiplied, remember that's what you need to move first because we're doing PEMDAS backwards. So you add and subtract first, and then you multiply and divide. Right, so we are left with 4b equals c minus AD, and we're going to divide by 4, right? We're trying to get this b alone. So we're going to divide by 4. And don't let the fact that there's a number in there throw you off either. It doesn't change anything. So we now have b equals c minus AD divided by 4. And that is your answer. All right, now this is a backtrack a little bit, so we're just trying to make sure that you guys don't forget any previous information because we need you to know it all, especially for that state test. So these are from past lessons, but hopefully you remember how to do them. So we're just finding the slope, the y-intercept, and the slope-intercept form equation. So remember we subtract up when looking at a table. So 3 minus 2, 2 minus 1, 1 minus 0. It's obvious that this side is moving by 1. Right? And we have 13 minus 8, that's 5. 8 minus 3 is also 5. 3 minus negative 2 is 5. And we can see that that pattern follows up the whole way, so this side is moving up by 5. Right? And if we remember, our slope is y over x, so our slope is 5 over 1, which is just 5. So m here equals 5. And then b is our y-intercept. And remember, we can find our y-intercept by looking at a table and looking for our x value of 0. So we have an x value of 0 here. So that means our b is going to be negative 2. Right? B is the y value of the y-intercept. So if it asks for the y-intercept, we would need the ordered pair. But it's just asking for b, which is our y value of the y-intercept. And now we can write our equation. Hopefully you guys have this engraved in your brain. Y equals mx plus b. So we just plug it in. Y equals 5x minus 2. Right? And when looking at a graph, we need to find our slope. So we need to find 2 points. Let's see where that second point really is. Make sure you don't pick like right here or here where you're not exactly at a meeting point. So we're going up 1, 2, 3. We're going over 1, 2, 3, 4, 5. So we go up 3 and over 5. And we can't reduce that or change it, so m is 3/5. All right, remember b is our y-intercept, so where are we crossing this y-axis? Well, it's right here. And this ordered pair is 0, -2. So our b is -2, just the y value. Now we can write our equation. So y equals 3/5 x minus 2. All right, now we were given two ordered pairs. So the first thing that we need to do is find our slope. And remember, we use y2 minus y1 over x2 minus x1. So that's what we're going to do. So we've got m equals -5 minus 3 over 1 minus -1, right? 5 minus 3, -5 minus 3, 1 minus -1. Right, so we have -5 minus 3 is going to give us -8. And then 1 minus -1 is going to be 1 plus 1, which is 2. And -8 over 2 can be simplified to -4. So that's our slope, our m. And now we need to find our b, right? So we can find our b by plugging in a y, an m, and an x and solve for b. So I'm going to use this first set of ordered pairs, this first ordered pair right here, and plug that in. So y goes first, so we have 3 equals m, which is -4, x, which is -1, plus b, which is what we're solving for. Okay, so now we have 3 equals -4 times -1 is going to become +4. And then we need to subtract 4 and move it to the other side to get b alone. So we get b equals 3 minus 4, which is -1. We can write our equation, y equals -4x minus 1. I don't mean to rush through these, but I feel like these are just review, so hopefully you guys understand those already. All right. A plant is growing 2 inches per week and was 3.6 inches tall when you planted it. The height of the plant Y is a function of the number of weeks. All right, so basically we just need to pull out some important information. So it's growing 2 inches per week, right? So we've got per right here. This is a rate word. So this is a rate word. And whenever you see your rate word, that is your rate of change. So we can go ahead and plug that in. So 2 inches per week is going to go right here. All right. It was 3.6 inches tall when you planted it. So that means its initial value was 3.6 inches. And then we just write our equation based on that. Rate of change, remember this is our m, and initial value is our b. So we just plug that in. Y equals 2x plus 3.6. And then 7, review again from previous lessons. Identify the following functions as even, odd, or neither. Well, remember that a graph that can be turned upside down and still look the same is going to be odd. So A is odd. All right, and then we need to look at our exponents here and decide. So we've got 6, which is even, 3, which is odd, and -7, which is a coefficient, which we know only is allowed in even numbers. So we have even, odd, and a coefficient, so this one's going to be neither. All right, we've got 6, which is even, 4, which is even, and 2, which is even. So this one's pretty straightforward. Obviously, we're going to be even. All right, now back to what we were covering in Chapter 4. Find the GCF and then write it in factored form. So remember, you can type these into your calculator. If you can't think of a common a common factor that's going to go into all three of these, your calculator will do that work for you. But remember, our greatest common factor is never going to be bigger than our smallest term because nothing bigger than 9 can go into 9. So we know we have to keep it at least 9 or smaller. So let's start with 9. If that's our biggest factor that we could have, does it work? Does 9 go into 18? Yes. Does it go into 27? Yes. So our greatest common factor is 9. And then we just want to factor it out. So we pull that out. 9 times what gives us 18x cubed? 2x cubed. 9 times what gives us 27x squared? 3x squared. And then 9 plus times what gives us 9, and it's just going to be 1. And you do need to include that 1, otherwise the 9 goes away, and you're just distributing it out to the first two terms. Okay, now we've got negative 4x to the 6th power plus 28x to the 4th power plus 16x squared. So let's start with the 4. Can 4 go into these? Yes, and remember it can't be any bigger than this. So we are negative leading here, which means our greatest common factor has to be negative. All right, so we know we're going to pull out negative 4, but then notice that there's x's in each one of these, and they each have at least 2 x's. So we can pull out x squared. And then we'll factor that out. Negative 4x squared times what is going to give us negative 4x to the 6th power? Well, all we need here is more exponents, so we have x to the 4th power. Remember, factors, these exponents are being added. When you multiply exponents, you add them. All right, negative 4x squared times what is going to give us 28x to the 4th power? Well, we need to switch our signs here and make sure that it turns out positive. So a negative times a negative is going to give us a positive. Negative 4 times negative 7 will give us 28, and we need 2 more x's. Negative 4 times negative what is going to give us positive 16? And the answer is negative 4. And we don't need any more x's, so that is the end right there. All right. So once again, negative leading. Will 3 go into all of these numbers? The answer is yes. And they don't all have x's. So we're just going to pull out our negative 3. Negative 3 times what gives us negative 3x to the 4th power? X to the 4th power. I don't know why it keeps doing that. And then negative 3 times what is going to give us positive 39x squared? Well, we need another negative, and the number is going to be 13. And we need our x's, so x squared. The negative 3 times what is going to give us negative 15. Watch your signs here. We need to multiply by a negative to get this positive, and we need to multiply by a positive to make sure this stays negative. So negative 3 times positive 5 is going to give us negative 15. Okay, 15x squared and negative 35x. Well, let's look at our smallest number first. 15 will not go into 35, so we know it's got to be smaller than 15. So our next common factor is going to be 5. And so the coefficients factor is 5, but we also have x values in each, so we can pull out 5x. So 5x times what is going to give us 15x squared? 3x. And then 5x times what is going to give us negative 35x? And the answer is negative 7. And you can always double check your work on these by factoring it back out and making sure you get the answer, the problem that you started with, okay? All right. Number 9 says, Michelle is selling chocolate bars for $3 for a fundraiser in band. She spent $15 to buy her first box of chocolate to sell. She needs to make a $60 profit. Answer the following questions based on this situation. So let's break down what it's telling us first. So she's selling chocolate bars for $3. So that means each bar is going to be $3. So if we're $3 per bar, We put in that rate word, so this is our rate of change. All right, she spent $15 to buy her first box of chocolate. So that means she's negative $15. She hasn't made a profit yet. She's spent money. So that's going to be minus 15. This is her initial value. She's initially in debt, but she wants to make a profit of $60. Right? She doesn't want to make any more, doesn't want to make any less. She wants to make $60. So now let's fill out what we've got. We can start by making our equation, right? I know it's kind of all over the place, but it helps me gather our x and y variables. So we're going to be 3x minus 15, right? 3x is going to be 3 times the amount of bars minus 15 of her initial value. So we can look here and see that 3 times x, this x is going to be how many chocolate bars we sell. So x is our chocolate bars. And then y would be our total profit in dollars. All right, so now let's fill out our chart. Remember, it's always x and y. We know our x value is the amount of chocolate bars. So we're going to start at 0. She sold no chocolate bars, and she's in debt $15. But we want her to get to $60. So let's first figure out how many chocolate bars she has to sell to make $60. So we'll plug in 60 for y. So 60 equals 3x minus 15. We'll add 15 to both sides. We get 75 equals 3x. We're going to divide by 3. And we get x equals 25. All right, I'm about to erase this, but we know that she needs to sell 25 bars to make $60. Okay, now I'm going to get this out of the way. So that means our last number, she's going to sell 25 chocolate bars and make her $60 back. Okay, so we'll go one above this, and then we'll do our dot, dot, dots. I know this is kind of an unusual method, but it's what makes sense to me, and maybe it will make sense to you. So we'll do one more. So if she sells 24 chocolate bars, remember we're selling them for $3, so she's got a $57 profit. The reason that I'm doing it this way is because we don't have room to go 0 through 25 all the way down. So we're going to do some dots and let that stand for all the bars sold that we don't have room for. So now we can fill out the rest of our chart. At 1 bar, she goes from negative 15 and she raises $3. So she's still in debt, but not as bad as she was. At 2 bars, she's still in debt, but not as bad as she was. Remember, we're adding 3. Each bar is $3. At 3 bars, she is at negative 6. We're going to go until she's at 0. At 4 bars, she's at negative 3. And then at $5, she's finally broken even, and she's got no profit, but she's also not in debt. So domain is our x value. So we've got 0 less than or equal to x less than or equal to 25. Remember, we do our first and our last x. Subset, if it starts with 0 and goes up, it's going to be whole numbers. And is there a constraint on this one? No, we're just increasing by 1, so there's no constraint. Our range is going to be negative 15 less than or equal to y less than or equal to 60. Our subset here, we've got negative, 0, and positives, so this has to be integers. Remember, integers is anything that you see on a number line. And if you turned this the other way, this would look pretty close to a number line. And our constraint here is multiples of 3. For every chocolate bar, we increase by 3. So that's reflected in the numbers that you see in your y values. All right, number 10 says to find the area of the shaded region, which is going to be this blue section right here. In order to do that, we need to find the area of the larger region and the smaller region and then subtract. So our larger region, remember, area equals length times width. So the larger region, we've got x plus 3 times 7x plus 5, and we just distribute that out. So we have x times 7x, 7x squared, x times 5 is 5x, 3 times 7x is going to be 21x, and 3 times 5 is 15. Then we combine our like terms. Oh, sorry, I forgot my x. So 7x squared, 5x and 21x makes 26x plus 15. All right, now let's find the area of the smaller region. So we have x times x minus 7. So x times x is x squared. X times negative 7 is negative 7x. All right, so now that we've got our areas, all we got to do is subtract. It's so important to make sure that you include these in parentheses because the parentheses are potentially going to change it, right? If it's adding or if it's subtracting, it may change what's inside the parentheses. And in this case, we're subtracting, so it's definitely going to change the parentheses, what's inside the parentheses. Because if you remember, we have to distribute this negative out. So this first part's going to stay the same. And then we distribute this negative out. So negative times x squared is negative x squared. And negative times negative 7x, it becomes positive 7x. And now we combine our like terms. So we have 7x squared and negative x squared. That's going to give us 6x squared. We have 26x and 7x. That's going to give us 33x. And then we're left with positive 15. So this is the area of our shaded region. All right, it says Sean is working extra hours to pay for a new phone. His base pay is $145 and he earns $9.50 for every extra hour he works. If the amount of money Sean earns, Y, is a function of the number of extra hours worked, X, then write an equation relating X and Y. So all this is saying is to write a slope-intercept form equation. So he earns $9.50 for every extra hour of work. So that's $9.50 times the amount of hours he works. So that is going to be our rate of change. And then his base pay is $145. So regardless of how many hours he works, he's making $145. So this is our, wait, I can't spell, initial value. So then we just plug it in. So we have Y equals 950x plus 145. All right, now it says, how long will it take Sean to earn $240? Well, it says that the amount of money Sean earns is our Y value. So we just need to plug 240 in for Y and solve for X. So we have 240 equals 950x plus 145. We're going to start by subtracting 145. We're left with 95 equals 9.50x. We want x alone, so we're going to divide by 950. All right, and then we get 95 divided by 950 equals 10. So it will take Sean 10 hours. Remember, it's important that you write this in the correct unit. It asks you, how long will it take Sean? So you can't just write 10. 10 what? 10 minutes, 10 seconds, 10 hours? We need to know how long it's going to take him. All right. So it says, using the graph shown, answer the following, write your response using interval notation. So all we're doing is finding our interval notation, which is we've already done. All right, so it says to find an interval in which the graph is increasing. So let's see what we're doing here. So we're increasing, and then we're decreasing, and then we're increasing again. You can't really see that. So we're increasing, we're decreasing, and we're increasing again. So it says to find where we're increasing. So we stop increasing right at about -2. And we stop decreasing right at about 1.5. So we have 3 separate intervals. So we're increasing here and here. So we could write, remember this is a -4. I know it's blurry, but we have 1, 2, 3, 4. So we're starting at -4 and we're ending at -2 roughly. Or we could include this side and we're starting at 1.5 and going up to 3. Either one of these answers is correct. We're talking about this interval or this interval. And now it says to find an interval where the graph is decreasing, which clearly has to be our center interval. So we're starting at -2 and we're ending at 1.5. All right, number 13 says, describe the transformations that have taken place when compared to the parent function y equals x. So we have y equals 2x minus 6. And all we're doing is talking about transformation. So remember, we're comparing this to the parent function y equals x, which is also y equals 1x plus 0, right? So that's what we're looking at. So our slope went from 1 to 2. So we are 2 times steeper. And then our b went from 0 to -6. So that's a vertical shift down 6. Right? We went from 1 to -1/2. Well, first thing first, we had a sign change. We went from positive to negative. So we have a reflection. We went from 1 to 1/2. 1/2 is smaller than 1, so we are 1/2 times flatter. And then we went from 0 to 2, which is a vertical shift up 2. All right, we just have a few more questions. Hopefully you have stuck around and hung out with me and watched this video. The last is just to simplify the expression. So here we are combining like terms. We're adding and subtracting. So remember, when we add, nothing changes. We can just go ahead and combine like terms. So let's start with our greatest number of exponents. Right, so we've got x cubed. So we've got 8x cubed and -7x cubed. That's going to leave us with x cubed. 1x cubed, x cubed is the same thing, whatever makes you feel more comfortable. Right, and then we've got -5x squared y and 4x squared y. That's going to cancel out most of them except for 1, so -5 and 4. We're going to be left with 1x squared y. Oh, actually it's negative. I didn't notice that. -x squared y. And then we've got 2y and 8y, which is going to give us 10y. And this is fine if you write it this way, but it really should be written x cubed minus x squared y plus 10y. All right, b, we're adding once again, so nothing's going to change. So let's start with our highest number of exponents, which is 2x cubed y squared and 10x cubed y squared. So that's going to be 12x cubed y squared. Remember, we're adding these. We're not multiplying, so these exponents do not change. We're just combining like terms. All right, next we have -5y and 5y. Well, those are going to cancel out and go away completely. And we've got 7 minus 3, which is going to be plus 4. All right, now C and D, these are where we're subtracting, so these are where some things are going to change. So we have 5m plus 7m squared minus 11m cubed. That stays the same. And then because of this minus sign, everything behind it in this parentheses is going to change sign. So now we have positive 7m cubed, negative 8m, and positive 4m squared. And now we can combine our like terms. So first things first, let's start with our cubed. We have 7m cubed and negative 11m cubed. So negative 11 plus 7 is going to give us negative 4m cubed. Next, we'll move on to squared. We have 7m squared and 4m squared. It's going to be 11m squared. Now we've got 5m minus 8m. It's going to be negative 3m. All right, and last but not least, we have one more. Negative 10b plus 7b squared minus 1. This side stays the same. And this minus sign changes everything behind it. So negative 2b, positive 6, negative 5b squared. Okay, so let's start with our highest number of exponents. 7b squared and negative 5b squared. So 7 minus 5 leaves us with 2. Next we've got negative 10b and negative 2b, which are going to combine together to make negative 12b. And we've got negative 1 and positive 6, so it's going to be positive 5. All right, that is it for this study guide walkthrough. I really hope that this helped you guys. If you have any questions, please reach out to your teachers, and good luck on your test tomorrow.